All right, guys, we are back into our sections of notes for geometry. As I kind of mentioned in class, I'm going to still be making these videos. On this one, I'm not going to have my face showing, but in general, I'll try to get that back up because I know it's a little bit easier to follow along when you're watching me work all these out. But again, I wanted to make these videos so that you guys have something to follow along to, and I know a lot of you guys like to look back through the videos to make sure you are doing something right, or if you have any questions, you can watch me work out a problem again. So like I said, I'll try to make these videos. I will be doing in-person lectures as well, which means I'm going to try to make these videos a little bit shorter and try to run through things a little bit quicker. Okay, we'll see how that goes today. So first off, label for today, 6.1 or I guess really we should start with, if you have not already, you need to label our next unit. We're in unit 6, and we are talking about actually the label of or similar to the label for today, the unit 6 is going to be about triangle congruence. Triangle congruence. So as a reminder, before the break in unit 5, we talked about triangle properties, specifically all these little things that we know about them, and now we're dealing with triangle congruence, and we'll talk about what all that means. So 6.1 is the label for today, congruent triangles, just kind of getting an introduction and getting into the basics. And then we did this on the 6th of January. Okay, and our objective is we want to be able to identify the congruent parts of these congruent shapes and then be able to prove by the end of this that two triangles are congruent. Okay, and so we won't go through a full-out proof, but we'll see when we get through this here. So first definition, we're going to write down congruent polygons. Congruent polygons here. Okay, and what this means, polygon is just another word for shape. So congruent shapes are just two or more shapes, whose sides, or I should say, let's fix that, whose corresponding sides and corresponding angles are congruent. Okay, again, congruent polygons are two or more shapes whose corresponding sides and corresponding angles are congruent, or really congruent to each other. So for an example here, since we're dealing with triangles, might as well draw a couple here. So let's say, here I'll draw these to look very specific. Let's just draw a triangle here. If this is your first time viewing my videos, welcome back to my handwriting. It's not great, but that's why you listen, right? So I have the first triangle here. Let's just name it, for simplicity, ABC. And then right here, let's say we have triangle XYZ. Okay, and what we're saying with congruent polygons, because this could work for triangles, 4-sided shapes, 5-sided shapes, so on and so forth, what we're saying is that all of the corresponding angles, or angles that are in the same spot, are all the same measure. And then same thing with the side lengths. All the side lengths that are in the same spot are also the same measure. So for example, if I had triangle ABC and I said this was, let's say 5, 6, and 8, just for example, for the side lengths, if the other triangle was congruent, we're saying every single side length is also going to be the same. So this would also have to be 5, this would also have to be 6, and this would also have to be 8. Okay, this is going to be a huge piece of our chapters, being able to prove that different triangles are congruent. And then the same thing has to go for the angles as well. You have to have all three of the angles of one be congruent to all three of the other. So for instance, let's say 100, let's say 50, and 30. And remember, that goes back to one of those properties that we talked about. We know all the angles inside the triangle have to add up to 180. That means the other triangle has to be the exact same. So this angle would also have to be 100, this angle would also have to be 50, and this angle would also have to be 30 degrees. Okay, so just something to keep in mind there as we're looking at these triangles. Every piece of them has to be the same, as long as they're in the same spots. Okay, and then how do we know which pieces go with which? How do we know which points or angles are corresponding? That is where our congruent statement comes in, our congruent statement. Okay, our congruent statement says this, it tells us which points are corresponding. Okay, it tells us which points are corresponding. And what it looks like is we'd say this. If we're using the example above, we would say triangle, so just using the symbol for triangle, triangle ABC is congruent to triangle, and I'm going to use the 3 points from the other triangle, but I have to be specific about which points line up with what. So for instance, A here is the one that we named first. That lines up with Y. So I would say triangle Y. Okay, then we go with B. B lines up with X. And then last one, C here, lines up with Z. And I have to write it in this exact order, otherwise my triangle would be off, or these would not be congruent. Okay, I can't just go in alphabetical order sometimes. I have to look at which points line up with which. And when I see this congruent statement, I know that tells me A has to line up with Y, B has to line up with X, and then C has to line up with Z. Okay, we will use this as we work through these problems. Okay, so let's continue here. Moving on to example 1. Okay, so with this we have 2 different polygons. You can take a second, pause your video if you'd like, and sketch these here. Okay, but we're looking at these 2 polygons, and we want to list all the congruent parts of these polygons, and then at the end create a congruent statement. So when we're talking about the congruent parts, we have 2 main things that we're focused on here. We have the sides and we have the angles. So I'll start with the sides here. We're looking at the sides. So if I'm looking between one polygon to the next, we see all these dash marks and we see all of these little arcs that show us something about the angles. So we're going to focus just on the dash marks first. And remember, we've said, okay, if a line, for instance here, like line PQ has 1 dash mark, that is always going to be congruent to any other line that has that same dash mark. So for instance, PQ here would be congruent. Okay, if I look at the other polygon, notice that would be FG. Okay, PQ is congruent to FG. Notice it's not congruent to any other side length because no other side length just has 1 dash mark. They all have 2 or they all have 3. Okay, so I need to use that to write the rest of these statements here. So next one here, let's look at the line with 2 dash marks. So PS or SP, let's just call it SP for right now. SP is congruent to, and then we have in the other polygon, we see this side length here, DG or GD. And remember, we need to be specific about which point that we choose first. So notice in actually the first example, we had this here, and I actually want to switch this up here. I'm going to change this to GF. Okay, we notice SP would be congruent to DG. Trying to make sure that all of our points line up correctly. Okay, and then we continue here. Notice the rest of my side lengths between the first polygon and the second polygon all have 3 dash marks. Okay, and I know it's a little bit harder to tell since they're so small. But since they all have 3 dash marks, that means all 4 of them, I should say, are congruent to each other. So we're going to say SR is congruent to, okay, the side length in the other triangle, DE, which is also congruent to our last side length, RQ, which is also congruent to the other side length that we haven't named yet, EF. And again, I know all 4 of these side lengths are congruent because they all have 3 dash marks on them. Okay, and then looking at angles here, which angles are congruent? And in this case, just for the sake of simplicity, we'll just name the angles with 1 letter. Usually we name them with all 3. But let's start. I'll erase my little line segments here. Okay, notice here we have an angle with 1 arc, angle P, and that's going to be congruent to the angle with 1 arc in the other triangle, which would be angle G. Okay, and then we continue. We see we have 2 arcs on angle Q. That is going to be congruent to angle F, because again, those have 2 marks, 2 arcs, and they are not congruent to any other angles, because all the other angles would have to have the same amount of markings as well. And then we can do the last few here. So we see angle R has 3. So angle R here. And looking at 3 over here, we see that's angle E. So angle E here. And then last one that we haven't talked about, they all have 4. Angle S. And so does angle D. Angle S and angle D are congruent. Okay, so now I've shown all the side lengths, or all the pairs of side lengths are congruent. and all the pairs of angles are congruent. So now I'm ready for the final step, which is said we want to create a congruence statement. So that's just stating it out and making sure that we have the letters in the right spot. So I'm just going to say for this first one, we'll just call it polygon. Okay, and this one, it doesn't matter the order of the letters. We just need to name them all out. So let's say P, let's just go around, PQRS. Okay, polygon PQRS. We are going to say that is congruent to the other polygon here. So polygon. And this one, we do need to be specific about the order of the letters that we write. So notice P should line up with G. So I'm going to say G first. Q should line up with F, so I'm going to say F next. R should line up with E, and then S should line up with D here. And this would be my final congruent statement. Okay, the order of the letters is huge here because, again, it tells us which points, which angles, and which sides are corresponding. Okay, and that will help us on future problems. So let's look at a few of those here and kind of see what I mean. Okay, example 2 here. Again, you can take a sec and pause your video if you'd like to draw these out. But we're given that triangle ABC is congruent to triangle DFE. So again, notice we're not just going in alphabetical order when we name these. We're being specific about which points are corresponding. And we want to use this to find the values of X and find the value of Y. Okay, so if I look at these here, so I notice they're kind of arranged the same, which is helpful. So I see A and D, B and F, and then C and E. So I know that all the angles in one are going to match up to all the angles in the other, and same thing with the side lengths. So if I'm trying to figure this out, notice on one of these here, if I was trying to solve for X first, I have Y in the equation as well. So let's leave that for now, and let's see if we can figure out what Y is first on its own. Because I noticed here this angle is 8Y minus 5, and we see that corresponds to the angle B in the other triangle. And again, since we've said that these two triangles are congruent, that means all their parts are congruent. So that means angle B and angle F are going to be congruent, or in other words, equal to each other. So I can set these two angles equal to each other. I can say 99 equals 8y minus 5. Okay, I know that the triangles are congruent, so all the corresponding parts are going to be congruent. And now I can just solve here, so I can add 5 to both sides. When I do that, these cancel. I get 104 equals 8y. And then last step here, divide by 8. We're going to get y equals. And as always, you guys can do this in your head or type this into a calculator here. And this one, I believe, is actually going to come out to be decimal, possibly. Let me see here. I'll type this in my calculator as well. 104 divided by 8, and that does come out to be a whole number. That is 13. Y equals 13 here. Okay? So again, when we see problems with X and Y, try to figure out if we can solve for one of them first. Okay, now that we have this, we have Y equals 13. That's going to help us because we notice that we have this side length 2y plus X, and that corresponds to the side length that's in the same spot, which is 38. So I can go ahead and set those two equal to each other. 38.4 equals 2y plus X. And something else that's helpful, why we had to solve for Y first, is now we can plug that in and then solve for X. So I have 38.4. I'm going to go ahead and plug in 13 for Y. So we have 2 times 13 plus X. Continue here, 38.4 equals 2 times 13, which is 26, plus X. And then my last step here, subtract 26 from both sides. When I do that, I get X by itself. And then I have 38.4 to minus 26. And that's just going to give me 12.4. And this one does come out to be a decimal. Okay, and that's okay. All right, so notice again, we're just using these ideas of corresponding parts are always going to be congruent if, or as long as we said at the beginning, that the triangles themselves are congruent. Okay? Now we're moving on to the last piece here. One more thing that's going to help us as we're trying to reach our end goal of proving that triangles are congruent. And this is one of the theorems that we're going to use to help us with that. Okay, this is what we call the third angles theorem. Okay, and the third angles theorem says this. it says if two angles in one triangle if two angles in one triangle are congruent to two angles in another triangle, okay, I'll give you a sec to write all that. If two angles in one triangle are congruent to two angles in another triangle, then what I can say is their third angles, or the third angle of each of them, will be congruent. Okay, and I'll explain what this means more. But then their third angles, or the third angle of each of them, will be congruent. So if I was to write an example here, if I just want to see this real quick, again, we can just take a few different triangles. Let's make them right triangles to make it even easier to see here. Okay, I have two triangles here. And let's say we can name this here, let's say JKL and MNO. Okay, I have these two triangles here. I know they're both right angles, so I know at least that there's 90 degrees in each of them. And then let's say we were given that angle J is 40 degrees and angle M is 40 degrees. Okay, if I was given this information, well, number one, we know how to find each of those angles, angle L and angle O, because we know all three angles in a triangle are supposed to add up to 180. But what this means is if I see two triangles like this, I know that these last two always have to be the same. Because again, they both follow that rule. All three angles have to add up to 180. Okay? And that helps us because that means we don't have to necessarily find the angles or know specifically what measure they are, but that will help me to show that they are congruent. Okay? So using that in this last example here, again, you can take a sec, pause your video, and sketch this diagram here. In this case, we are told a lot of information, and we're going to try to prove that the triangles are congruent. And so using the definition of congruent triangles, the only way that we have to prove that so far is we have to show all the side lengths are congruent, and we have to show all of the angles are congruent here. So with that being said, let's do this here. So I'm not going to fill out a whole proof because I know how much you guys love those. Since it's the first day back, we'll just write out our explanation. So like I said, I have to show all the side lengths are congruent to each other from one triangle to the next, and then same thing with the angles here. Okay, we'll talk about the reasons, we won't necessarily write them down. So let's start with the side lengths here. Do we know any side lengths that are congruent from one triangle to the next? Well, we know we have one dash mark on DE and one dash mark on GE. So I can say DE is congruent to GE. Okay, check. Okay, that's one side length, one pair of sides that we know are congruent. And remember, we need to show all three pairs. Well, we look at our picture again, we see this next pair of sides, DF and GF, both have 2 marks on them. So I know those are congruent. So DF is congruent to GF. Okay, that's 2 sets of sides. And then the last set of sides that we haven't named is the same one, or the shared side, EF. Okay, whoa. Okay, EF is in both of them, right? Since it's the shared side. Okay, and what that means for us, or what we could say or make a statement of, is we could just say EF is congruent to itself. Okay, it's the same side length, so it has to be the same in each triangle. Okay, and this actually goes back to the reflexive property that we talked about last semester. We'll be using that more here. Okay, but we know all 3 sides just by looking at it. We know all 3 sides are congruent. Okay, that's good. Okay, now the question is, can we do the same thing with the angles? Because if we can do the same thing with the angles, then we're done. We've shown that these have to be congruent. So first pair of angles I see here, in this case I do need to name them with all 3 points because there's 2 angle Fs. I see angle DFE is congruent to angle GFE. Okay, since they both have 1 arc. All right, second one here, I see 2 arcs here, and I see 2 arcs here. So I know that angle, let's just say EDF, is congruent to angle EGF. for that same reason. I see the same amount of arcs on both of those angles. Okay, so I've named 2 of the angles here. I've named all 3 sides and shown that all these pairs are congruent. And now I just need that last pair of angles here. This last pair. I need to show that these 2 angles here are congruent. Well, that's where we would use this last theorem that we just talked about. The third angles theorem tells me if 2 angles from one triangle are congruent to 2 angles of another triangle, then I know the third angles have to be congruent. So my other statement that I can make here is I can in fact say angle, let's say DEF, is going to be congruent to angle GEF, okay, because of the third angles theorem. And if we wanted to, we could fill out a whole proof saying here's our given, here's these statements. We'd use the reflexive property, we'd use the third angles theorem. But in general, as long as we can just show this information, that'll be suitable for today, okay? So this is how you show, as of right now, that shapes are congruent. You have to show all the angles and all the side lengths are congruent to each other, okay? So homework assignment for today is 6.1 exit ticket. If you are online right now, just make sure to check the class website, but otherwise you should have gotten this or should have been handed this in class, okay? And as always, if you guys have any questions, feel free to let me know, all right? Thanks, guys.